On number 1 from the BAT list, you are to divide d of x into f of x and then write your answer in fraction form. So we can use synthetic division here because of the fact that our d of x is linear. So we start with the 0 of our factor, which is 3, and then we take the coefficient of the leading term and then take each coefficient in descending order. Remember that we need to put a 0 if there's any missing power of x, but in this case there's not. So we'll put 2, -7, 4, and then -5. Then we bring the leading coefficient down, multiply the 2 by the 3 on the outside, record the product, and then add those two numbers, and then multiply 3 by -1, we get -3. We add and get 1. We multiply 3 by 1 and we get 3. We add and get -2. And then we translate our answer into a quadratic because we started with a cubic and divided by a linear. So we get f of x equals 2x squared minus x plus 1, and then we put our remainder as a minus 2 over the factor we were dividing by, x minus 3. Then we go to number 2 on the BAT list, and this one we are to use limit notation to describe the end behavior of this function. We'll remember that the degree of the polynomial determines the direction the ends go, and since this polynomial has degree 4, which is even, means that if we have a positive leading coefficient, both ends go up. Well, our coefficient here is 1, which is clearly positive, so that means that the limit as x approaches either plus or minus infinity for this function f of x is positive infinity. And to justify that choice in writing, you would also need to note that a equals 1, which is greater than 0, and that's a completely adequate justification for your response. Number 3 on your BAT list, you are to locate the vertical and horizontal asymptotes only, and here, because our denominator can be factored, we should immediately factor it. So we have x in the first spot of each, and since our third term is subtracted, we know we're going to have a plus and a minus. We need the factor pair that multiplies to 3 with a difference of 2, and there's only one factor pair for 3, so we put the 3 with the plus, because you always put the bigger number from the factor pair with the sign of the middle term, and there is our factored denominator. So remember, your horizontal asymptote comes from a comparison of the degree of the top to the degree of the bottom. And since the degree of the top here is degree 1, the degree of the bottom is degree 2, this one is bottom heavy by Twitty's quick trick here. So since it's bottom heavy, we know we have a horizontal asymptote at y equals 0. And then our vertical asymptotes happen at the denominator's factors, which don't cancel. Let's try that again. I was trying to circle the denominator here. And so we know that we're going to have vertical asymptotes at both x equals -3 and x equals +1. And that's all you have to do for that one. On number 4 from the BAT list, we are to use the remainder theorem to determine what the remainder would be if we divided f of x by x plus 2. So remember, that means that we substitute into the function, that's what the remainder theorem tells us, we substitute into the function the value of x that makes our factor 0, or in other words, the 0 of our factor, which in this case would be -2, and then we get 3 times -2 cubed minus 2 times -2 squared minus 2 minus 5. And then we use our order of operations to clean that up. So that is negative, because a negative 2 raised to the third power is still negative. So then that's negative 3, we pull the negative out front, times 2 cubed would be 8. And then we have a negative 2, and then negative 2 squared would be times positive 4, minus 2 minus 5. Simplifying one more time, negative 3 times 8 is a negative 24, minus 2 times 4 is 8, minus 2 minus 5. So since everything here is being subtracted, we would add all these terms together. Negative 24 minus 8 would be negative 32, minus 2 would be negative 34, minus 5 would be negative 37. And that would be the remainder if we divided f of x by x plus 2. On number 5 from the BAT list, you were to complete the exploration on page 160, which is really just exploring writing the equation of a line in an application situation. And on page 160, we can read that Camelot Apartments bought a $50,000 building and paid, and for tax purposes, they're depreciating it at $2,000 a year. Well, that means that the initial cost, or the initial value of the building is $50,000 because that's what they spent on it. And depreciating implies that we are losing value, so we would say that would be a negative $2,000 annually. All right, and then number 1 says, what is the rate of change of the building? Well, that implies, or the value, rate of the change of the value of the building, well, that's just negative 2,000. And remember, rate of change, and I'm going to abbreviate that ROC here, if I can write this late at night. Which, remember, anytime you see rate of change, that's slope. So we already know the slope of our line. And then number 2 says write an equation of the line, or the linear function, really. It actually doesn't use the word linear, but this is a linear situation. Write an equation for the value v of t. So it says to call our equation v of t. And to me, if you know your initial value, or if you're given your initial value, it just makes sense to start with the initial value, and then to apply so this is basically your b, where we have mx plus b, but we're reversing the order, and then minus 2,000 t. And that takes care of number 2, because we were just to write that equation. And then number 3 says to compute v of 0 and v of 16. In other words, figure out what this building will be worth initially. Well, again, we already know that that should be 50,000, so when you plug in your initial value like this, then when you plug in 0, you should get back your initial value, and we do, because 2,000 times 0 is just 0. So our initial value is, or our v of 0 is 50,000. And then our v of 16 is 50,000 minus 2,000 times 16. And 16 times 2 is 32, so that means we're doing 50,000 minus 32,000, which is going to be $18,000. So according to our data here, our information, the building will be worth $18,000 in 16 years. And then number 4 says solve v of t equals 39,000. Well, that's pretty simple. We're just going to replace v of t with 39,000, and then copy the other side of our initial equation. Well, if we add or subtract 59,000 from each side, that would give us 11,000 on the left equals negative 2,000 t. And then if we divide both sides by Oh, I left the negative off my negative, I'm sorry, off my 11,000. So subtracting 50,000 from 39,000 would give us negative 11,000. And then when we divide both sides by negative 2,000, we get that t is 5.5 years. Let me try that again. And we're done with number 5, and that's the end of this segment of the bat list.